In the fourth and last part of this chapter, we're going to talk about media access control. So media access control is the lower sublayer of the data link layer, and it actually controls the placement of these frames across the shared medium between multiple devices. So basically, it deals with the topology of the local area network, and it tries to control the sharing of the LAN shared media amongst multiple users. So we have to set some rules on when each node can actually access the medium. So the MAC layer defines two different types of topologies, or they differentiate between the physical topology of the network and the logical topology of the network. The physical topology of the network defines how the physical devices are connected together. So you have different machines, and they are connected using a switch, or using a hub, or using a router, and so on. So the connectivity between these physical devices and the different machines is what we call the physical topology. The logical topology, on the other side, refers to the fact of how the frames are transmitted over the medium. In other words, if you have two or more machines are sharing a particular line, we represent that using a shared bus like this. If you have two or more networks, two or more of these networks are connected to a router, we represent that using a connection between the network and the router, in which case the bandwidth between the different connections of the router will not be shared. So the bandwidth is shared amongst these devices, the bandwidth is shared amongst these devices, but there is no data link layer sharing between the two networks. So basically, the hub is one single broadcast domain. So all these classroom machines are represented using one machine, and we will talk about the function of the hub later. Whereas a switch can actually facilitate the sharing of bandwidth between multiple devices across the switch bandwidth here, and it facilitates the connection to a network layer device like a router, as we can see. So that's why these classrooms are represented using one machine in the logical topology, and all these machines, all the machines that are connected to a switch are represented using a bus, as we can see here, to symbolize the fact that these machines, they all share the medium, or the switch, in that case using technology like Ethernet. So the logical topology is the type of topology that actually identifies and determines the access technology used. With that said, there is the WAN topologies, and there is the LAN topologies. There are common types of topologies that are used within a wide area network, and there are some topologies that are used commonly by LAN networks. So for the case of WAN topologies, very frequently we use point-to-point to facilitate the communication between two nodes, or two WAN devices. Typically, these devices are routers, and you have one wire that connects those two routers. We also use hub and spoke topology, which is represented using a star. So typically, you connect multiple nodes to a centralized device here, which acts as a facilitator of communication between all these devices. So all the communication that happens between these devices, it has to pass through that centralized point, and this actually represents the physical topology for a hub, which connects multiple nodes together. Also, the mesh topology, which connects off multiple point-to-point connections between a group of devices. So each device here is connected to all the other devices using point-to-point connection. Of course, mesh topology is rather complicated, and in terms of maintenance, it's the most expensive amongst all these topologies due to the fact that you have to maintain full connectivity between all these devices together. So the physical point-to-point topology is represented by one WAN connection which connects two devices like this. So point-to-point is limited to two devices. This is the simplest type of topologies, of course, and it's the easiest in terms of facilitating the access to the medium between these two devices. Because the participating devices here is only two, the access to the medium will be rather simple, and there are some simple protocols like PPP protocols which are used to organize the access to the connection in that case. So for logical point-to-point connections, the two nodes might be connected using WAN connection like this. However, in the middle here, there could be multiple network devices that are coming in the way, and they look like they could contain like some switches, some other routers, and some hubs, and so on. And in that case, this physical topology, it actually facilitates point-to-point connection between those two routers in the logical sense. In other words, those two routers, they use logical point-to-point topology, not physical, because the physical topology actually contains many other devices in the middle. Very frequently, the logical point-to-point connection like this, they use access method which uses some type of a virtual circuit. So a virtual circuit facilitates the connectivity or the communication between two nodes across a logical point-to-point link, as we can see here. So the logical point-to-point is using a virtual circuit, whereas the physical topology uses multiple devices which can use different link access technique on the different links here. But on an end-to-end basis, this is a logical point-to-point connection. So using this point-to-point connection, the connection can be accessed in a form of full duplex or half duplex. So half duplex represents the access to the medium in a time fashion, which means that it's a one-way street, and it can be used in either direction at different times. In one time, it's used to facilitate the communication in this direction. In another time, it's used to facilitate the communication in the other direction. Whereas for the case of full duplex, the two devices can send and receive at the same time, providing two-way street between the two communicating entities. LANs, they tend to use topologies like star topology. So you have many participating devices which are connected using a hub, and or extended star topologies, in which case they can be connected through multiple LAN devices like a hub or a switch in a star-like fashion. Or there are some legacy physical technologies. So the bus topology uses some kind of a legacy technology which provides a physical bus which acts like a chain, and all these nodes are connected to the chain using different types of connectors. And this type of physical topology is really kind of obsolete. And also we have the ring topology, which connects all the devices using not a bus in that case, but a ring. So in that case, the ring has no termination. So the bus here has two terminations, whereas the ring has no termination in that case, in which case the frames will go in circle between all the devices. It's worth noting here that those two physical topologies are rather obsolete, and they are not used anymore in recent LAN technologies. Okay, so in terms of medium access control, there are two types of access. We have the contention-based access, in which case all the participating nodes here, they are allowed to send on the medium whenever they have data ready. So whenever a node has a data ready, it's allowed to send the data on the network. And as we can see, if we imagine ourselves in a meeting and two people talk at the same time, potentially we will not be able to distinguish what they say. In which case we call this, in LAN technologies, we call this a collision. So those two frames will experience a collision. So, contention-based access techniques, they suffer from a collision problem. Whereas controlled access, each node will be allowed to transmit at different times in the medium, in which case each node will have its own turn to send over the shared medium. So all the other nodes will have to wait for their turn. In that case, if we organize this carefully, we can have no collision in that case. So controlled access is collision free. Is completely collision free, whereas contention-based access, they suffer from collision. So contention-based methods, the devices can attempt to access the frame whenever they like, in which case we need some kind of a technique to organize the access to the shared line. We use some kind of a carrier sense multiple access technique, and the way that this technique works is the fact that each node will, before it tries to send anything on the line, it actually listens to see if there is any transmission that's currently happening on the line, and that can be detected easily using some measurement of the energy on the line. So if the energy on the line is high, this means that someone else is transmitting. In that case, this node will abstain from transmitting over the shared line. If the energy level on the line is low, this means that nobody else is sending on the line, in which case I can actually send on the line. So this is what we call carrier sense multiple access. One thing to note here is that carrier sense multiple access does not eliminate the collision, and that's because of a simple fact that two nodes might be actually trying to sense the line at the same time, and they both discover that the line is empty, in which case they send at the same time and the collision happens. In that case, we need some other technique combined with the carrier sense multiple access to act in case of a collision that happens. For the case of Ethernet, we have the technique of collision detection, which means that similar to the fact that we listen to the transmission of other nodes, we can also detect that there is a collision, in which case a node, when it sends, it actually listens to the line to see that whether there is a collision on the line or not. If there is a collision on the line, the energy level on the line will tend to be very high, in which case we detect that there is a collision and we stop transmission and we wait until the line is totally clear. If there is no collision, then we declare that the transmission of this frame is successful and we move on to the next frame. However, in the case of wireless, the detection of the collision is very hard, and that's due to the fact that the signal travels through the air with many other transmission of other nodes, and the detection of the collision is high in that case, in which case we use another technique which is called collision avoidance. For collision avoidance, what happens is that the nodes do not detect the collision, but they try to avoid that the collision happens. And they avoid that through, before sending the frame, they send a simple small signal to indicate that I'm interested to send over the shared medium, and then the other nodes will try to listen to that simple signal to see that this node is trying to send, in which case they will abstain from sending anything in that case. So the difference between collision detection and collision avoidance is that for collision detection we detect the collision, but for collision avoidance we try to indicate our intention for transmission using a request signal before we actually start transmitting anything. So the logical multiple access topology works like this. So if node A wants to send anything to node E, for example, then A will check first that there is no transmission on the line. So if there is no transmission on the line, A will start transmitting. When A transmits a frame, all the other nodes will be able to listen to that frame. Of course, because the frame is distant to node E, only node E will be able to consume it. But before E actually consumes the frame, node B wants to send something to node D. Node B, of course, will find the transmission line busy with the first frame, so it will abstain from sending anything. After E receives the frame successfully, node B will now detect that there is no transmission happening on the line, and then it starts to send. So this carrier sense multiple access allows us to always listen before transmission. If we find that the shared line is busy, then we abstain from transmission. If we find that the line is empty, only then we can transmit. And this way we can reduce the collision but not eliminate it completely. So when using the controlled access on the other side, controlled access provides turns for each node to access the line, in which case if each node has its own turn and it does not transmit any data in other times, we can organize the access to the transmission medium, in which case we eliminate the collision completely. This type of controlled access is used by Token Ring or 802.5, and it's used by FDDI for using fiber optics to have controlled access to the line. And to understand the difference between, again, contention-based and controlled accesses, again, if we imagine ourselves in a meeting and we have a moderator who gives each one a turn, in which case we will never have collision. Otherwise, for contention-based, if two people are allowed to talk at the same time and there's no moderator in the meeting, then we will potentially go through some collisions or some interruptions, in which case we will have to, one of us has to stop to leave the shared floor to others to talk. Token Ring uses, again, controlled access technique, and in that case, each of these nodes will have its own turn. So if A has its own turn now and it wants to send to D, it sends a frame which goes around the ring in one direction until it goes to D. So when it passes through B, B will check the address in the it's not the target of that frame, then it passes it to the next node, and then it goes all the way up to D, and then D checks the physical address to realize that this frame is distant to D, in which case it consumes the frame and it stops at this point.